Good day, grade 12 honesty. Praised be Jesus and Mary. Welcome back to our general physics class. For today's discussion, we will talk about kinematics of translation. Before we start, I want you to open your book, your general physics book at page 58 for you to be guided as well. Lesson 3.1 at page 58 talks about kinematic equations of motion. Okay, kinematic equations of motion. And wonder what comes in your mind when you hear the word, right, kinematic. So motion, or the study of motion, is divided into two, kinematics and dynamics. Kinematics describes motion in terms of displacement, velocity, and acceleration, while the second one, dynamics, when you say dynamics, it is the study of force in relation to motion. So in this lesson or in this discussion, we will only focus on the concept of this term, kinematics, which means we will talk about, or we will talk more about displacement, velocity, and acceleration. You will also know the difference between distance and displacement, speed and velocity, just like that. Okay, so before we start the discussion, I want you to take note of these equations right here. These are the 5 important equations that we are going to encounter along the discussion. Alright, so we will start with distance versus displacement. What do you think is the difference between these two? Right, we will start with their verbal definition. Okay, so distance is a scalar quantity, while displacement is a vector quantity. By definition, distance is the total length of path taken by a moving object from its initial position to its final position, while displacement is the straight line distance between an object's initial and final positions, of course, with direction toward the final position. So let me give you an example to prove that these two are really different from each other. So, example, a student walks 100 meters from his house going to his school. So let me give you an illustration. So this one is the starting point. This is the house of the student. And this point right here is the school. Okay. This is 100 meters. So when you are asked what the distance is, or how much is the distance taken by the student from his house to his school, you would obviously answer 100 meters, since the path he has taken is from this point to this point is 100 meters. But if the student goes back from, so let's say he's from his house going to school, and then to school going to his house, that is another story. So if that's the case, you can form an equation for distance that is from here to here, that is 100 meters. Since he goes back to his house, he would take another 100 meters. So you have already x sub 1 plus x sub 2. X sub 1 is from here to school, that is 100 meters. And x sub 2 is from school to going back to his house, which is still 100 meters. So the total length of path is 200 meters. That is the distance taken by the student from his house going to school and then going back to his house. Well, in displacement, the case is different since this is a vector quantity in which you have to consider the direction of the student walking from his house, going to school, and then going back to his house. So we will copy the illustration. Okay, so still we got 100 meters. The displacement in equation form is represented by delta x equals x minus x sub 0, where delta x is the displacement itself, x is the final position, and x sub 0 as the initial position. Okay, so let's have the first case in which the student walks from his house to school. So if we would say, okay, using this equation, I'm going to write it again. Using this equation, when the students, first case where the students goes to his school from his house. So the house is considered, or this point is considered the initial position. At the initial position, of course, 0 pa siya kay starting point man. And the school is the final position. From the initial to final, you have 100 meters. First case pa niha, wala pa siya ni uli sa ilaha. In that case, our final position is 100 meters. And our initial position is 0, since starting point siya. So 100 meters minus 0 is equal to 100 meters. So this one is the displacement of the student when he walks from his house going to his school. So second case is when the student from his school goes back to his house. So, pila naman ni ka points? 1, 2, then ibalik siya sa ilaha.
Before we start, I'd like to make the term translation clear to you. Diba? I have introduced to you the topic which is kinematics of translation. So the term translation there, or the term translation is used in physics for motion in a straight line. So straight line, it could be horizontal, vertical, or yes, horizontal or vertical. But this time, we will focus only on one-dimensional motion, particularly the x direction or the horizontal line. That means we have to consider two directions, either the negative side or the positive side. Or basing on the compass, that could be west or east, since we are only focusing on the horizontal line. So let's start. Since we are solving for displacement, we have here two paths already, from the house to the school and then from the school going back to the house. So that means we are going to formulate the equation delta x sub t equals delta x sub 1 plus delta x sub 2, meaning we have two displacements involved in here. Okay, so we will solve first for delta x sub 1. So delta x sub 1 is the distance or the displacement rather from the house going to the school. That is final position minus the initial position. So in that case, the final position is from the house to the school, that is 100 meters. And the initial position is obviously 0 since it is a starting point. Okay, so the 100 meters here is positive since it is going or directed east or onto the positive side of the Cartesian plane. That is 100 meters minus 0. The first displacement is equal to 100 meters, or delta x sub 1 is 100 meters. And for delta x sub 2, okay, this time the displacement is coming from the school going to the student's house. That means the sign for the value of the final position becomes negative since it is directed to the opposite direction or the opposite side. Same equation or formula, x minus x sub 0. X is for final position, x sub 0 is for initial position. The final position is now, or the initial position for x sub 2 or delta x sub 2 is now from school. And the final is here. That means from school to the house, that is still 100 meters, but the direction is changed or the opposite already. That becomes 100 or negative 100 meters. Still, the initial position is 0 since it is the starting point. Negative 100 meters minus 0 is negative 100 meters. Okay. So for the displacement or the total displacement, we simply add delta x sub 1 and delta x sub 2. Delta x sub 1 is 100 meters and delta x sub 2 is negative 100 meters. That means if we add them together, we will get 0 as the displacement or the total displacement. Therefore, if the student walks from his house going to school and then he goes back to his house, his initial position and final position is the same. The straight line distance is equal to 0, and in calculation, the result is also 0. Therefore, the displacement of the student from his house going to school and going back to his house is equal to 0.
Okay, we will now proceed to speed versus velocity. These terms, speed and velocity, are commonly used interchangeably in everyday situations. However, in physics, they have different meanings. So when you say speed, it is by definition the distance traveled by a body in a given time. It is a scalar quantity. It does not involve direction since we are talking about distance. While velocity is the displacement of a body in a specified time interval, meaning speed is scalar, velocity is vector. Speed deals with distance, while velocity deals with displacement. The equation generally is presented as v equals x over t. So if you are, or depending on the quantity that you are referring to, if you are referring to speed, then you can have v as speed, x as distance, T is time. So that is for speed. But if you are referring to velocity, then you can have V equals, this is by the way a small letter v. V equals delta x over t or delta t, where v is velocity, delta x is displacement, t is time. Okay, so generally it is presented as v equals x over t. The only difference is whether x represents distance or displacement. Okay, so let us go directly to sample problem 3.2 at page 60. By the way, you can check your book at page 60 for the derivation of this formula I have presented here. Sample problem 3.2. The situation is Vanya walks to her school 360 meters away at a constant speed of 3 meters per second. 10 seconds later, his brother Angelito follows at a constant speed of 4 meters per second. The question is, first, or letter A, how long will it take Angelito to overtake Vanya? So it is referring to time. The term how long refers to time. And the next question, or letter B, how far is Vanya from school when overtaken by Angelito? When you say how far, you are referring to the distance. Okay, so we are going to summarize first the values that we are going to use for the solution. So the distance 360 meters. That is the distance from Vanya's home to her school. Another is Vanya's speed. So we are going to use V as the variable for speed. Speed V sub V, since it is Vanya's speed. The small letter v here, or the subscript v here, stands for Vanya. So that is equal to 3.0 meters per second. Okay, 10 seconds later, his brother Angelito follows at a constant speed of 4 meters per second. So Angelito's speed, that is V sub A, is 4 meters per second. Okay, so in dealing or in solving this problem, we are going to deal with the equation of speed, since this case talks about the equation of speed is V equals x over t. So V equals x over t. We already have here the given speeds of Vanya and Angelito. And then next we will find out their distances and time. So Vanya's time could be T sub V. Vanya's time is, it is not directly stated in the problem. What is stated there is 10 seconds later. So the exact time that Vanya traveled was not stated. It was said that 10 seconds later, Angelito started or followed Vanya. So this will be the time Vanya walked before Angelito follows her. Before Angelito followed her, this T, mono siya. And then plus 10 seconds. Where is this 10 seconds coming from? From the statement, 10 seconds later. Okay, next is so Angelito's time is unknown since it is the quantity that is asked in the problem for letter A. How long will it take Angelito to overtake Vanya? So dili na to siya mabutang dira. Next is the distance traveled by both Angelito and Vanya. So we will start with Angelito's distance. X sub A. Anong distance sa ibabaw? This is from their home to the school. So X sub A, Angelito's distance is not directly stated in the problem. So we have to analyze by using this equation here. This is speed, distance, and time. So since we are dealing with Angelito's distance, we would say V sub A is equal to, or Angelito's speed is equal to Angelito's distance over Angelito's time. For us to be able to get the distance, we are going to manipulate this equation here. That is by cross multiplying. We got XA equals V sub A times T sub A. And then substitute the value of V sub A, which is 4.0 meters per second. And then T sub A, since that is unknown. Alright, so Angelito's distance is equal to 4 meters per second times Angelito's time. Next is Vanya's distance. So, X sub V. For Vanya's distance, we have V sub V equals X sub V over T sub V. We need to manipulate this one again. We have X sub V equals V sub V times T sub V. Vanya's speed is given and her distance is not clearly or directly stated in the problem. That's why we have to do this process. Okay, so V sub V is 3 meters per second. Vanya's time is we also have here Vanya's time. So we can substitute the value of T sub V in here. That is T plus 10 seconds. So Vanya's distance is 3 meters per second times T plus, or the quantity of T plus 10 seconds. As what I have told you, summarizing the values you are going to use in the solution or in solving the problem is very important for you to be guided, because these are the values you are going to consider or to use. Okay, Angelito's distance, Vanya's distance. So we will proceed now to the solution. Okay, the question is, how long will it take Angelito to overtake Vanya? So we are asked what time or how many seconds will Angelito have to take for him to overtake Vanya. So to be overtaken, Angelito's distance must be equal to Vanya's distance. That is, through equation or in equation, can be presented as x sub A equals x sub V. Eh, di ba? Gi-overtake. Kung overtaken ka, of course, ang distance nga inyuhang ma-cover should be equal. So, ang Hilitos distance is equal to Vanya's distance. And then, the next step is simply substitute x sub A, the value of x sub A, and the value of x sub V. X sub A is 4 meters per second times t sub A, and x sub V is 3 meters per second times t plus 10 s. So what's the next step? Since you have here quantities that are enclosed by an opening and closing parenthesis, of course, the first thing you have to do is to distribute 3 meters per second to these quantities here. 3 times t, 3 meters per second times t. Or you can have it kana siya. 3 meters per second times t. And then, na lang. And then, 3 times 10 seconds, you get, copy the plus sign, you get 30. The unit meters per second will become, madali na ako sa ibabaw, ibutang, meter per second times second, it will become, so makancel ang S. What's left is the unit meter. So mauni siyang naadiri. Okay. So this time, we are going to combine like terms. Since we have here 4 meters per second t, actually you can disregard this subscript A here since it stands for t para dili makuha ang equation. Nakuha na lang nako ni para di mo malibog para makombine na to ang like terms from this side, which is 3 meters per second t to 4 meters per second t. Ako lang sa i-copy. Ako na lang i-change ang parenthesis para di mo malibog. Okay, so what will happen next is we are going to combine like terms. So 4.0 meters per second t plus i-transpose na to minus i-transpose na to 3 meters per second t. Of course, it will become negative. What's left in the right side is 30 meters. So as you can see, we have here the same quantities or the same terms. 4 meters per second minus 3 meters per second t is 1 meter per second t. Copy 30 meters. What are we looking for? We are looking for the value of t. So we have to divide both sides by 1 meter per second for us to cancel out this value. Para ang mabilin si t na lang. Cancel, cancel. Okay, so t or ang Hilitos time (3 divided by 1) 30 divided by 1 is 30. What will happen to the unit? So, diri na ko isolve ang unit para makita ninyo unsa ang process meter. Okay, what happened to the unit? So, this is the process. Meter divided by meter per second. You can have it multiplied, but change the positions of S and M. Since gi-multiply naman nimo siya, instead of M in the numerator, it goes to the denominator and s to the numerator. Okay, so if you multiply, ang mahitabo is meter times second divided by meter. Makancel ang meter. What's left is second. So we have Angelito's time. You can put already t sub a here. Angelito's time is 30 seconds, or he took 30 seconds to overtake Vanya. Okay, next is letter B. Question letter B is, how far is Vanya from school when overtaken by Angelito? Vanya's distance from school when she was overtaken by Angelito. So first, we solve for the distance traveled by Vanya when Angelito had overtaken her. What equation are we going to use? Same equation, V equals x over t. We are going to manipulate this equation to come up with Vanya's distance from school when she had been overtaken by Angelito. Wait lang. So, since we are dealing with Vanya's distance, we are going to use V equals x over t with the subscript V to represent that this is referring to Vanya's distance. Okay, since we are looking for distance, we have to manipulate this equation again. It becomes, cross multiply, x sub v equals t sub v times t sub v. So we will simply substitute the values of these quantities. We have already here Vanya's speed. Vanya's speed is 3 meters per second. We will use this one. We will substitute this value to v sub v. And Vanya's time, or t sub v, is t plus 10 seconds. So directly substitute 3.0 meters per second times t sub, t only, t plus 10 seconds. We are done substituting the values of v sub v and t sub v. Since we have already the value of time, or t, we need also to substitute that value here. Copy 3 meters per second. Time is 30 seconds plus 10 seconds. 30 plus 10 is 40 seconds. 40 seconds times 3 meters per second, you have for a 12 meters. What happened to the unit? Meter per second. Di rin ako i-solve ang unit para makita ninyo ang process. Cancel. What's left is meters. So, mauna ni siya nga unit. Alright, so Vanya's, wait, it's not 12. It's 120. Sorry for that. 120 meters. Vanya's distance. So Vanya's distance is 120 meters. That is, Vanya's distance when overtaken by Angelito is 120 meters. But the question in letter B is Vanya's distance from school. That means, if this is their home, this is the school, and Angelito or Vanya was overtaken by Angelito at this distance, the remaining distance is the answer for letter B, or answers the question Vanya's, or how far is Vanya from school when overtaken by Angelito. That means 360 meters, since 360 is the distance of Vanya and Angelito's house from school. We need to subtract, or 360 meters need to be subtracted by 120 meters. So 360 meters minus 120 meters equals 360 meters minus 120 meters is 240 meters. Therefore, Vanya is 240 meters away from school when overtaken by Angelito.